In this video, we are going to play around with making 2D, also known as co-spectral plots. So what we're looking at here is a false color image of beautiful Santa Barbara. There's Campus Point right here. Wonderful surf break. You can see the airport and all sorts of wonderful things. Here's downtown Santa Barbara. But again, the purpose of this is not to enjoy the beautiful geography of Santa Barbara, though that's something you can readily do, but to look at co-spectral plots. So again, we've got this Landsat image collected in 2000, and right now we're displaying a false color image. This is a looks like it's a 4-3. Oh, actually no, this is the one that we're actually showing. If I expand this, is a 5-4-3. So we're looking at a 5-4-3. And I want to do a co-spectral plot of this one. The easiest way to get to this is under Display and a 2D scatter plot. And so what just showed up here is this plot, which has on this axis band 5, and on this axis band 4. And we can change these bands easily if we want to, but basically what all this black stuff represents, these are all of the pixels in the scene plotted with their band 5 value against their band 4 value, right? So that's what all these pixels are. If I want to change the band, I want to make it band 6, I can do that. If I want to make it band 1, I can do that. If I want to plot band 4 against band 4, I can do that. It's a perfectly straight line. That should make sense, right? Because whatever the value is for band 4, it should match the value for band 4, since that's what we're plotting. That's not that interesting, so let's look at other things. This is pretty cool because we can, and if we think about band 4, right? Band 4 is near infrared. We're getting into some longer wavelengths out here. If I move it into the visible, right? So blue, green, red, and so on. The basic pattern holds. If we look at visible light, this is now band 1 and band 2, we can see very strong correlation, right? So typically if things are bright in band 1, they're also bright in band 2. If they're bright in the blue, they're bright in the green, and these different things can come out. This is now near infrared over here on this axis, and then we've got green light over here on this axis. And so that's cool enough, but what we can also do here is we can draw and highlight particular populations of pixels. So these pixels up here are interesting. These are high value in the near infrared band 4 and low value in band 2. So let's actually we're going to draw around and let's see what happens. And all of these guys just lit up. Hopefully you guys can see that, right? So we're isolating out these particular regions in our image which might be of interest for whatever reason. We cared about the ones which have a strong reflectance in band 4 and not so much in band 2. That's pretty cool. We can add different colors to this if we wanted to. I'm going to make this guy yellow. Let's say I want to focus on the ones which have high values in both band 4 and band 2. I don't know if you guys noticed, but a few of these guys are popping out. I'm going to expand this region a little bit, right? We're starting to get the areas which are bright in both of these ones. We could add another class here. Let's make it blue. This is a little bit of foreshadowing. All right, so and I'm going to draw ones which are low in both of these guys. Bang, right? So there's some interesting things you can do with co-spectral plots, and this was what this introduction was about.